Hi class, in this video we're going to move into section 1.5 and this is going to be talking about differentiation techniques and it's the power and sum rules. So basically what's going on here is if you looked in this previous section, section 1.4, we looked how to find the derivative or complete differentiation by using the limit rule. And so what I want to do in this video here is just show you a bunch of shortcut methods for this. Okay, so the first thing we'll start with is what's called Leibniz notation. Okay, Leibniz's notation. And it goes like this. When y is a function of x, okay, so we have this function, okay? Y is equal to some function of x, okay? Doesn't matter what it is, okay? We'll even do a simple one, maybe just something, like this. We'll actually work this in a little bit, okay? We'll designate the derivative, okay, which we'll denote as f prime of x. And so remember what the derivative is. The derivative is a function that gives the slope of the tangent line to f of x, to the original function at some x. Okay, so you plug in some x to this. So we would denote this. Another way of writing f prime of x is as dy dx, and this is this notation up here that I'm talking about. It's just another way of calling it. So we read this as the derivative of y, that's derivative of y, that's what the top stands for, with respect to x. So the denominator here is telling us what variable we're going to differentiate with respect to. All right, in class you'll hear me through these videos call it dy dx, okay? So these are other common forms, okay? All of these are other ways to show the derivative, okay? So if you have some function like y is equal to f of x, which is equal to x squared, all of this notation would be the derivative of this. Okay, so now let's figure out, or let's find some rules, some easy rules for finding the derivative of some function, okay? And so the first one is the most important rule, and it's called the power rule. And it says for any real number k, if you have y is equal to x to the k power, then, okay, these are similar notation that I want to talk about here. The derivative of y with respect to the x variable of our function, x raised to the k power is equal to, look what you do. You just bring the k down in front and you multiply it by x to the k minus 1. Or another similar notation, I would say take the derivative with respect to x of x to the k. And all you're doing, okay, this, I know it seems silly, but if you have x to the k, to find the derivative of this, any function of this form, you take the k, you bring it down in front, then you multiply it by x times k minus 1. Let me show you that this works, okay? So for y is equal to x squared, okay? Find y prime, or dy dx, doesn't matter, okay? Well, the way I had shown this to you, okay, and here y is a function of x, okay? The way we had done this before was we looked at the limit as h goes to 0, all right, of f of x plus h minus f of x all over h. So the limit as h goes to 0 of, so I'm finding it for x squared, it would be x plus h squared minus x squared all over h, which then becomes the limit as h goes to 0. If you FOIL this out, you'd get x squared plus 2xh plus h squared minus x squared over h. Well, look what happens here. The x squareds cancel, and an h squared factors and h factors out, and you cancel here, and you're left with the limit as h goes to 0 of 2x plus h. Well, just h goes to 0, and you're just left with 2x. So this is how you used to do it, okay, in the previous section, section 1.4. And this is not fun. It's a lot of algebra. So you can actually just use the power rule here, okay? So we have y is equal to x squared. Y prime, the derivative. Well, k here is just the number 2. So I'd bring the 2 down in front. So I'd be left with 2x. And then I'd take the exponent and write it as 2 minus 1. Well, 2 minus 1 is 1. X to the first power is just x. Look, you get the same thing. So you don't need to do this limit formula anymore. You can just use this power rule, and it'll work for any x, or x raised to any power k, where k is a real number. All right, let's just this lecture here is just going to be a ton of examples. So let's just work on. All right, so I've got these 4 functions here. Okay, let's differentiate each of the following. So y is equal to x to the 5th power. So the derivative y prime, which can also be written as dy dx, would be equal to, well, my k here is 5, so bring the 5 down. X, take 5 minus 1. So this is just equal to 5x to the 4th power. And that's it, that's the derivative. Here, again, y prime, which is the same thing as dy dx. Well, to help you solve this, to find the derivative of just x, rewrite this as x to the 1st power, okay? So you're going to bring down the 1, and it's going to be 1 minus 1. Well, you get 1 times x to the 0 power. Well, anything raised to the 0 power is just 1. Here, the derivative, I'll just write it as dy dx here. Take this negative 4, bring it down in front, x, and then you have minus 4 minus 1. Well, look, minus 4 minus 1, you get minus 4 x to the minus 5 here. You can even rewrite x to the negative 5 power as minus 4 over x to the 5th power, right? Just using our basic rules of algebra. And then even if you have something like x to the 15, right? dy dx, the derivative. Bring the 15 down in front. And then I'm just going to quickly shorthand this. Just, well, what's 15 minus 1? Is 14. And that's it. So in all these cases here, you just bring the exponent down in front and then subtract 1 from the exponent. All right, let's try these where it's a little bit harder. So this one is a radical, okay, this first one here. Okay, y is equal to the square root of x. Well, the trick here for this problem is you need to rewrite the radical as an exponent of 1/2, right? So you would just rewrite this as y is equal x to the 1/2 power. Now dy dx, the derivative, bring down the 1/2, then you would have x, you would have 1/2 minus 1. Well, what's 1/2 minus 1 is minus 1/2. So we can leave it like this, or you can even write it as 1 over 2x to the 1/2 power, which is the same thing as 1 over 2 square roots of x. Or, I mean, you could even rationalize the denominator here and write this as the square root of x over 2x. Okay, but generally, this, just leaving it as this is fine. But these are other ways you could show it. All right, even this where you have a decimal, dy dx. Bring down the exponent, and then take the exponent up there and just subtract 1. So you get 0.7x to the minus 0.3. And that's it. I'll just add another one here just so you can see something else here. All right, suppose I have the 4th root of x. Okay, well, you can rewrite this as x to the 1/4 power. Now dy dx, again, just bring down the exponent, x, and then you'd have 1/4 minus 1. Well, 1/4 minus 1 gets you minus 3/4. Okay, so hopefully, just exponent, all it is, whoop, bring the exponent down, and then subtract 1 from the exponent, and that's your derivative. All right, just so a few other rules. The derivative of a constant function is 0, always, always, always. So for example, if I say y is equal to 7, okay, then that means dy dx, no matter what it is, okay, is just 0. Derivative of a constant is 0. Even if it's something like this, y is equal to pi squared. Well, then dy dx, you got to remember pi is just a constant, right? It's just a number, 3.14, da 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 da. So the derivative of this is still 0, okay? So whenever you see a constant and you differentiate it, you find the derivative, just equal to 0. All right, the next one, the derivative of a constant times a function is the constant times the derivative of the function, okay? So using the derivative notation, we can write this as the following. If I say find the derivative with respect to x of some constant times a function, really what you can think about it, okay, basically is you can factor out the constant. I'm going to show you 2 ways to do this, but you don't, whichever one is easier. I find that the second way I'm going to show you, where you just kind of skip a step, is a little bit easier actually. So let's put this to practice. All right, suppose you have this one here. Okay, I have these problems here. So the first one says find the derivative with respect to x of 7x to the 4th. Well, what you could do here first is you could factor out the 7. So it would be 7 times the derivative with respect to x of x to the 4th. All right, well that becomes the 7 stays, bring the 4 down, and then 4 minus 1 gets you 3. And then all you need to do is 7 times 4 gets you 28, okay, times x cubed. What I actually like to do is I just leave the 7 as is, and then I say, okay, immediately bring the 4 down. So you see how I'm kind of skipping this middle step? And then x to the 4 minus 1, and you get the same thing. Okay, so here, this one here, the derivative here, when you take this, right, so you have the negative 9 times x. Okay, well, what's the derivative of x? Let me just go back real quick. We saw this. The derivative of x is just 1. So this right here, the answer is just negative 9 times 1, which is just negative 9. Okay, here, this one, the way I tackle this problem, okay? So the first thing here is this 1/5, I'm going to factor out like this. It's 1/5 times 1 over x squared. I'm going to take the 1/5. I'll actually bring this out just so you can see what I'm doing. Times the derivative with respect to x. I'm going to rewrite this, okay, because this doesn't look like x raised to a power. This is where it gets a little confusing. I'm going to actually bring this up as a negative exponent. X to the negative 2. Okay. So now I have 1/5. Bring the exponent down, negative 2 times x to the negative 2 minus 1. Well, 1/5 times negative 2 is negative 2/5. X minus 2 minus 1 gets you x to the minus 3, which you can then write as minus 2 times 5x cubed. Same thing. Okay, both those answers are the same. The second part here, I'm just bringing the negative exponent down. All right. The last major theorem we have here is the sum and difference rules. So the sum and difference, so it doesn't matter if it's the sum or the difference, but the derivative of a sum is the sum of the derivatives. So if I have something plus something and I'm telling you to find the derivative of it, you're really just finding the derivative of each term. That's it. And it's the same thing with the difference. If I'm telling you to find the derivative of a function minus another function, just differentiate each of the functions here, or each of the terms in the expression. It's really straightforward. All right, let's take a look here. So this first one here, let's find the derivative with respect to x of 5x cubed minus 7. Okay. Well, here, just go take the derivative term by term. Okay, so this is 5. I'm going to bring the 3 down using the power rule. X to the 3 minus 1. And then just remember, what's the derivative of a constant? Well, that's minus 0. Okay, derivative of a constant always 0. So then 5 times 3 gets me 15. And then x to the 3 minus 1 is x squared. All right, even before I tackle this one, like the square root and 5 over x, I'm going to rewrite it so it's just a little bit easier. Derivative with respect to x of 24x. I'm going to rewrite the radical as x to the 1/2. And then this I'm going to bring up as x to the -1. All right, now I'm ready to differentiate here. All right, well, the derivative of just x is 1, so it's just 24 times 1. Minus, bring the 1/2 down, x to the 1/2 minus 1, plus 5, bring the -1 down, x to the -1, and then I have to subtract 1. So I'm just going to clean this up a little. So this is just 24 minus 1/2, x 1/2 minus 1 gets me minus 1/2. 5 times -1 gets me minus 5. And then minus 1 gets me -2. So I will just say this, just always be mindful of the negatives. You know, for as long as I've been teaching these courses, students generally get mixed up when things involve fractions or negatives. So just take a little bit of extra time on some of these. All right, let's just do this one now. We'll do a crazy one here. Okay, so y is equal to 3x to the 5th plus 2 times the 3rd root of x plus 1 divided by 3x squared plus the square root of 5. Okay, so y prime here, okay, which is dy dx, same thing. All right. If it helps, before I even do that, let me rewrite some of these things. So this is 3x to the 5th plus 2 times x to the 1/3 power, right? That's what I'm bringing that up. Plus 1/3. This x squared comes up as x to the -2 plus the square root of 5. Okay, so this one's easy. Just bring the 5 down. So this is 3 times 5. And then 5 minus 1 gets me x to the 4th. Plus 2, bring the 1/3 down. X to the 1/3 minus 1. Plus 1/3, bring the -2 down. X to the -2, and then I have to subtract 1. And then remember, even though this, don't fall for this, the square root of 5 is just a constant, so that derivative is 0. So then 3 times 5, that gets me 15x to the 4th. 2 times 1/3, gets me plus 2/3, and then x, this is x 1/3 minus 1, right, is minus 2/3. 1/3 times -2 gets me minus 2/3. And then this is x minus 2 minus 1 gets me x to the -3. So as you can see here, this is just a lot of algebra using this power rule trick. It's just a lot of algebra. Okay. Let's end by doing this one last example. And it says, find the points of the graph of this function. F of x is equal to minus x cubed plus 6x squared, at which the tangent line is horizontal. Okay, so tangent line is horizontal. Okay, so a horizontal tangent line has slope because it's a horizontal line. Okay, so remember, what does the derivative gives us? The derivative gives us the slope of the tangent line. So let's find the derivative, f prime of x. All right, so for this, to find the derivative, f prime of x is equal to, well, just going to use the power rule here. Bring the 3 down. So minus 3x squared. Plus, bring the 2 down. So 2 times 6 gets me plus 12. And then I have an x here. All right, so then here's the thing. Now I need to find, remember, this function gives the slope of the tangent line. Find when f prime of x is equal to 0. So all you're going to do is you're going to set equation equal to 0 and solve. All right, right, so f prime of x is equal to minus 3x squared plus 12x. You have to solve when it's equal to 0. Well, to do this, factor out a minus 3 and an x. You're left with x minus 4. So you have two solutions here, right? You have when minus 3x is equal to 0, or you have when x minus 4 is equal to 0. So this solution here is obviously x is equal to 0, and this one is when x is equal to 4. So here's what's going on. You know you have horizontal tangent lines to this graph when x is equal to 0 and when x is equal to 4. All right, so what it asks, though, you have to be careful of. It asks to find the points. All right, so f of x here was equal to minus 3x cubed plus 6x squared. And you have horizontal tangent lines at x is equal to 0. So plugging in 0, f of 0 here, you should get, just plugging in 0, 0. So 1 point is at the point 0, comma 0. And then the other place where it occurs is when x is equal to 4. So f of 4, if you were to plug 4 into this, right, you'd get minus 4 cubed plus 6 times 4 squared. You have to be careful here. So 4 cubed is 64, and then the negative is outside, so this is minus 64 plus 4 squared is 16 times 6, I believe, gets you 96, which is 32 here. So the second point occurs at the point 4 comma 32. And on this last slide here, what I'm going to show you is the graph, and you can see the horizontal tangent lines here at these points 0, 0, and 432. So you can see this is what the graph looks like. It has a horizontal tangent line at the origin, whoosh, and then it has another horizontal tangent line up here. All right, class, so just the power rule here, just in summary. Okay, remember, bring the exponent down in front and then subtract 1 from the exponent, and that gives you the derivative there.